Hey class, so for today we're going to be talking about the chain rule, and for those of you paying close attention, do not worry, this is not 2413, this is math 1325. I just caught that typo just now. Okay, so let's go ahead and talk about this handout. We're talking about the chain rule. You can find this in chapter 4.4. What is the chain rule? Why do we care about it? Basically, let's say we have a function inside of a function. This is something that happens very often. Then you will want to be able to still take the derivative of this case, and that's where the chain rule comes into play. So, for instance, let's take a look at this function right here. And just as a reminder to you all, what does this mean? This is simply f of g of x. And so we could rewrite this as f of g of x, and we're just taking the derivative of that thing, right? That's just different nomenclatures. Just make sure you're aware of them. So we're trying to take the derivative of this guy. Note that that guy is, in fact, a composite of two functions. What two functions? It is this guy and then this guy, right? Because this is the square root of x minus 5, right? X minus 5 square rooted. So that's what's going on there. So how do we get through to this? Well, we are going to be appealing to the formal definition, maybe, where we go, okay, well, what would this look like? Because we don't have a theorem. Well, if we were to do that, we would say the limit as h approaches 0 of x plus h minus 5 square root minus the square root of x minus 5 square rooted, all divided by h. Now, this is certainly doable, although it would be nice to have a rule that we could use that would make this easier, so we didn't have to appeal to the formal definition of the derivative every single time. So enter the chain rule. So for the chain rule, we're using two basic assumptions. The first assumption is that g of x is continuous. And differentiable. Alright? And so the next one is that f of x is simply differentiable at g of x. Alright, so they basically have to be differentiable in either way. I guess I'm being a little redundant by putting it this way, since in order for something to be differentiable, it must also be continuous. But it is correct to say it that way, so we'll just leave it as such. So if we have this case, then we are in this situation where we can say that f prime of f of g of x, right? That's what this nomenclature means again. This is f of g of x, right? And we are taking the derivative of that. Just a reminder, just nomenclature. Let's not let nomenclature get us down. And so, the way we will take the derivative of this will simply be df with respect to g, dg with respect to x, right? Where f is a function of g of x, and g is simply a function of x. All right, so we're going to switch to Leibniz notation, and we're going to let y equal f of u, where u equals g of x, right? And so in order to write this more succinctly, we're going to make these substitutions, and these are both differentiable functions. Okay, and then we can say what is dy dx, right? Y is a function of f, f is a function of u. So we would say simply the derivative of f with respect to u, derivative of u with respect to x. And so a lot of the times you'll see it written like this: f prime of u multiplied by u prime. You'll hear me saying this a lot. Basically, a way you can remember this is the derivative of the outside times the derivative of the inside. So if you are so inclined and can speak out loud where you're sitting, I want you to repeat after me. The chain rule is the derivative of the outside multiplied by the derivative of the inside. All right, if you can just keep that in mind, that is what the chain rule in effect is. So let's get to our motivating example. Square root of x minus 5. How do we do it without having to go through the formal definition of the derivative? Well, first we identify the inside function, which I will be highlighting in yellow here. And let's go ahead and write that. We're doing our let u equal x minus 5. We're going to be finding the derivative of this guy. So, and again, that is the derivative of the inside bit. So u prime of this guy is 1, right? Or 1 plus 0, because the derivative of x is 1, the derivative of negative 5 is 0. All right, so that is our derivative of our inside function. Let's go ahead and highlight that a different color. Highlight that in green. Okay. And now let's go ahead and find our outside function. Well, our outside function, that's f of u, which, is the yellow part. So this is simply the square root of u. And now we want to find out what is f prime of u. So we're going to take the derivative of this guy. F prime of u equals. Alright, so for those of you who are maybe a little rusty on the square roots, let me go ahead and explain this one. The square root is actually the same thing as taking a 1/2 exponent, right? Those are equivalent, they're exactly the same. And so we're going to go ahead, let's go ahead and highlight that outside bit right there. Right, so that we can kind of see all that is in fact equivalent to each other. Okay. All right, so now we're going to take the derivative of what you see here, and we're going to be using the power rule. So the exponent comes out into the front, so we have 1/2 multiplied by u, and what is 1/2 minus 1? It's going to be negative 1/2, right? Because we are subtracting 1 off of that 1/2 to get this guy right there. All right, that's just our power rule in action. All right, so let's go ahead and put this down. So we're going to go ahead and write our formula out, u prime, right? That is our d of f of x with respect to x. That's how we do this one. All right, so we're going to go ahead and continue our color codes. Let's go ahead and, now this is the derivative function, so it looks a little different now. So we'll highlight this guy in a different color. And we still have our yellow right there. Okay. Alright, so hopefully those color codes makes everything really obvious with what's going where. So we're going to write this out. So we have 1/2 put our yellow highlight there, go back to red, 1/2. And then we'll go ahead and throw that there. And so keep all the highlights still in order. There we are. Okay, so our u is simply x minus 5, right? Because that's what how we're defining it. And then our green, that is simply 1. So we can write this as 1/2 x minus 5 to the negative 1/2 power. Another way to write this, if you're so inclined, this is a perfectly acceptable way to leave it, by the way, but the negative exponent forces it into the bottom, and so you could write this as 1 over x minus 5 to the 1/2 power. Don't forget that 2 there. Or you could even write this as 1 over 2 times the square root of x minus 5, right? And those are all equivalent ways to write the same thing. I'm not really partial to any one of these three. It kind of all depends in the context, what's the best one to report. But you should be comfortable with any of these notations. Just make sure you know that they mean the same thing. Okay, so this next guy, we're going to do the same thing. I recommend you hit the pause button and try and work this one out on your own with the strategies we just put in place. And so now let's go ahead and check it to make sure that your work was correct. All right, so we defined it, our u. Equals x plus 5. All right, leave it like that. Take the derivative. Like so. Okay, so now let's find out what is our f of u. Well, that is u to the second power. All right, and then keep going, and now we find f prime of u, which is 2 times u. And now we put everything together. And let's stick with the highlight convention that we've been using. Okay, oh, and that is a u right there. Alright, so go ahead and write this all out. So we have 2 times the guy in the yellow times the guy in the green. Alright, and then you can write this more succinctly. Highlight that. I think there we go. As equals, or you could distribute that 2 so that you have 2x plus 10. Either way are acceptable ways to report that answer. All right, so the last one. Let's identify our u, which is this guy here. And then, sorry, x squared. I think I got used to the other problems. X squared, and then u prime now is 2 times x. And now let's identify what f of u is. Well, f of u is simply e raised to the u. Alright, so f prime of u. Well, we know that the derivative of e to the u is simply e to the u. It's its own derivative. That's what makes this function so unique among all the other functions. It is, in fact, its own derivative. And we note that it is still a function of u. Stop. Sorry, my dog is biting my hand. All right. Stop. All right, and then what is the derivative of this whole thing? Well, that is, of course, our formula, f prime of u times u prime. just like so. And let's go ahead and fill everything in. U is simply x squared. The green is 2 times x, and that's our answer. 2x times e to the x squared. Alright, and that's it. That's how we work this whole thing. Let's go ahead and move on. We kind of jumped into this without a proof, and I'm not going to go into the full die-hard proof of this, but instead we're going to go through a little semi-proof, just enough so we can kind of have a good idea of where this is coming from. It kind of give us an understanding of what's going on. So first what we're going to do is we're going to let u equal g of x. Right, that's kind of what we've been doing, and this is for when we're dealing with, f composite g of x. Remember, this is f of g of x, right? That's all that means. Okay. And so, if we say what is g prime of x, well, that's the same as u prime of x, which is du dx, right? Because u is considered a function of x still. And then we can rewrite this as du equals u prime dx. Okay, so far so good. All right, so now what about f prime of u? Well, this is simply df du, right? And then again, this is the same as what's going on over here. So df equals f prime of u times du. And note, we have an expression for du. It's right here, u prime dx. Alright, so we make the substitution. We've got df equals f prime of u multiplied by u prime dx. Right, still staying color-coded here. So now all we have to do to find out what f prime of u is divide by dx, so that we have derivative of f with respect to x equals f prime u multiplied by u prime. Alright, so this might look a little bit confusing at this point, so let's work this way, just to kind of remind ourselves, what is df dx? Well, what is f? F is a function of g, which is a function of x. And we're taking the derivative of that with respect to x, right? That's what that would mean. So, and so that should help hopefully give you a better understanding of where this is coming from. Like I said, it's not a complete proof. The full-on proof is half a page long, and so I figured this was sufficient to help us with understand what was going on. All right. So keep going here. I don't know why that just bothered me. Okay. So the derivative of e raised to a function. Not sure that'd be. So the derivative of e to the g of x. Well, so what is g of x? G of x is simply our u function that we were looking at earlier. And so we got, let u equal gx. And so what is u prime? U prime is simply g prime of x. Okay, cool. And so what is our f of u? Well, f of u is simply e raised to the u. And so f prime of u equals e to the u. All right, so let's put all this together. Again, what does this equal? This equals f prime u times u prime. And so when we look at this, this is simply going to be u prime times e to the u, which again is another way of saying g prime of x times e to the gx. So the important things to watch here are that when you're taking the derivative of this guy, you take the whatever function you have up here, that's going to stay the same. And then in front, you're going to put in the derivative of that exponent. And that's it. That's how you take the derivative of these guys. Alright, so let's go ahead and just kind of give you a quick example. Let's say I've got e to the 2x plus 1. And I want to find the derivative of this guy. Well, so first thing I do is I take a look here and I think, okay, what is the derivative of that? It's 2. And I put that in the front. And then I say e, and I just repeat what was already up there. And that's it. That's the derivative. Simple, quick. All right, so let's use this for the b raised to the x. It's going to be not as quick, but it's going to be pretty quick to go through this proof and work through these. So first thing we do is we're going to use our hint, right? We're going to use that rule there. So this is going to be the derivative with respect to x. And so we're going to say that of e raised to the natural log of e raised to the of b raised to the x. Okay, so this is using our knowledge that a logarithmic and a exponent are going to be inverses of each other. So for instance, if I say what is 10 raised to the log of 5, well, the answer here is going to be, just keep in mind it's always going to be base 10, right? The answer is going to be 5, right? Anytime you have the exponent and the base are identical, well, then you know that the answer to that question is going to be whatever's hanging out up here. And so that's why we can write this in that way, because, you know, the bases match here and here, and so that means that we can just put this out in the front, and that gets us back to where we started. Okay, so if we can do that, that means it's correct. So let's go ahead and make this more differentiable. We have the derivative with respect to x of e raised to the x times the natural log of b. Okay, not too bad. So natural log of b, keep in mind, is just a number. You know, like 2 or 5 or 6, right? This is just going to be a number right here, not the x part, but this part right here. Okay, it's going to be an irrational number usually, but you know, ultimately it's just a number. So when we take the derivative, you know, we're just going to look at this guy and ask ourselves, well, what's the derivative of this, right? Well, what's the derivative of a constant times x? It's going to be that constant, right? And so that's what natural log of b is. It's a constant. So it's going to, when we're looking for the derivative here, we're going to bring that constant in the front, and the x drops off, right? So that's what I'm highlighting in yellow. That is the natural log of this guy right here. All right, so then we just write everything else as it was, e to the natural log of b times x, and so this becomes the natural log of b times the e times the natural log of b raised to the x. And so note, you know, this is what's in the exponent, and these two bases match up here, e and natural log, and so it becomes natural log of b times b raised to the x. Right, and that's it. That's our formula. So our formula is nice, simple, easy to use. It's just like the derivative for e to the x, except we have this extra term right there. So let's go ahead and take a look at this first example. What is the base? Well, the base is 5, right? Our b, right? Our b is 5. It's like it, see right there. Go 5. All right, that's good. And then we're going to follow the normal rules for this guy. So first we're going to say 2t times the base 5 raised to the t squared. So note that, we didn't discuss it over here, but we're simply following the same guidelines as we have up here. Right, this t squared became this 2t, derivative of the exponent, and the exponent stays in there. So, like I said, very similar to the regular exponential problem with an e, but just with that little added step in there. All right, so this next one, our base is 10, so when we find what is the f prime of this guy, first we take the natural log of the base, and then multiply that by the base times x plus 1. Here, what is the derivative of that exponent? Well, that's simply 1. So we go right here, but we just the 1 is implied, so we don't have to write it. All right. Last one, back to the exponential. We have an e with this exponent right there. And so when we take the derivative of this guy, this is 2x, right? Because that's the derivative of this, multiplied by e to the x squared plus 1. And that's it. That's the derivative for that guy. All right, so like I said, these are pretty nice, pretty straightforward to work with. You just got to always know what case you happen to be in. So let's go ahead and look at this last set for the day. Natural log of x. And this should read g of x. And so let's go ahead and fix that. So we have the derivative with respect to x of the natural log of g of x, like this. Okay, so if we have this set up, what is the derivative? So first we say, okay, well, what is our u? That's this guy here. And so u prime is going to be g prime of x, and our f of u equals the natural log of u, and the derivative of the natural log of u is 1 over u. All right, so let's go ahead and rewrite this in those terms. This is going to be f prime of u times u prime, and so we have 1 over u times u prime, and so this becomes the original function over the derivative. And that's it. And so you can also write this as u prime over u if that is an easier way for you to remember. Alright, so let's go ahead and differentiate the following. We have the natural log of g of t. Also, as a reminder, this is going to be g prime of t divided by g of t. There's what there. And so this next one, we've got natural log of x squared, so we have so first we look what is the derivative of this guy. That's going to be 2 times x. Then we put the whole guy right there, x squared, right? The derivative of the top over the bottom. and this simply becomes 2 divided by x. Alright, awesome. So this one, I think this one should be just the log of x squared there, so make sure you put that in there. So let's find this guy. Note that this is going to be base 10. So on these instances, when you find the derivative, it's going to be the inside derivative of the inside, divided by the inside. The only difference is now we're going to take the natural log of b and stick it in the bottom. Alright, so f prime of x, so we've got the derivative of this, which is 2x, and then divided by the bottom function, which is x squared, and we just make sure we include a natural log of the base in. And so you can see that depending on which base you use, the derivative is just off by a constant. Okay, so I hope that helps get everything across. If you guys have any questions, send me an email, and good luck on the homework.